Alright, so we've been looking at how to identify transformations from what we know as vertex form of a quadratic function. So given g of x here equals negative 0.75x squared plus 2, we need to be able to recognize the negative 0.75 as our a parameter. And since the plus 2 follows the x squared quantity, that would be our k parameter. Looking at the a value, we look at its sign first, and it is negative, so that tells us that we do have an x-axis reflection. Second, we look at its absolute value. And the absolute value is by definition distance from 0. So that's always a positive quantity, so that would be positive 0.75. And here we compare to 1. And being less than 1, that tells us that we have a vertical compression. And our factor for that compression will be the 0.75. Then we look at our k parameter. And k by definition is that plus or positive 2. And that tells us we'll have a translation up the 2 units. And then we put it all together into our comparison statement. So compared to f of x equals x squared, g of x has an x-axis reflection. A vertical compression, by a factor of 0.75 or 0.75. And a translation up 2 units. Alright, so taking a quick look at one more of these types of problems. So here we have g of x equals, we have a negative here, which we should realize represents a negative 1, times x plus 6 quantity squared minus 4. So the negative sign, as I said, represents negative 1, so that would be our a parameter. The opposite of the plus 6 would represent our h parameter. And what follows the quantity squared represents our k parameter. So first looking at the sign on our a value, which is negative, tells us that we do have an x-axis reflection. Then we must look at, still dealing with a, its absolute value. The absolute value of negative 1 is 1. And remember, we compare this value to 1. And if it's greater than 1, we have a stretch. If it's smaller than 1, we have a compression. And here we actually get 1 equals 1, which we need to understand means there is no stretch and no compression. Then moving on to the h parameter. So we have to be careful that we get the right sign here by taking the opposite of the plus or positive 6. We get an h of negative 6, which tells us that our translation here is to the left of 6 units. And then finally looking at k, what follows the quantity squared is by definition k. So k is negative 4, which tells us we have another translation down. And we can put all of that together. So we have compared to f of x equals x squared. G of x has an x-axis reflection. And a translation. Left 6 units. 4 units. Alright, so now we're going to move on to a different type of problem. So in this type of problem, we're looking, given the graph of f of x equals x plus 3 quantity squared minus 5, the question is, how does Mary create the graph of g of x equals x minus 1 quantity squared plus 1? The difference here is that we're creating a transformation in g of x, but we're starting with a parent function f of x that is actually itself already transformed from the parent of the family. So this is a strategy that we can use pretty easily. We would find and graph the vertex of the f of x function, find and graph the vertex of the g of x function, and then determine the translations necessary to move from f of x to g of x. So what we need to know is that, by definition, the vertex of each of these is the point h, k. So their h and k parameters are the vertex of each. So for f of x, the vertex would be -3, -5, where h would be the opposite of the +3, which is -3, and k would be the -5. And for g of x, the vertex would be 1, 1. The opposite of the -1, giving us the h value here of 1, and the +1 here, giving us the k value of 1. So then, making a quick sketch, and it doesn't have to be a perfect graph, you don't need a lot of detail, you're just trying to get to see the relationship between the 2 points that represent the vertices of the parabolas. So for f of x, we have a vertex of -3, -5. So that would be here. So there's the vertex for f. And then the vertex for g of x is at 1, 1. And then what we do is look at how to move from one to the other. So starting at f and going to g, we have to move to the right 1, 2, 3, 4 units. And then we have to move up 1, 2, 3, 4, 5, 6 units. And then that becomes what we'll explain as far as how Mary creates the graph of g of x. So Mary can create the graph of g of x by translating f of x, right 4 units, and up 6 units. All right, let's take a look at one more of those. All right, so here again, we're looking at Mary wants to create g of x starting with f of x. So we want the vertex of f of x. And that vertex would be -2, 7. The h, again, remember, being the opposite of that +2 to give us -2. And the k being the +7 or +7. And for g of x, the vertex there would be -8, +2. So taking the opposite of the +8 would give us that h value, and the same as that +2, that's the k value. So now looking at graphing each of these. So here we have at -8, +2, this is our g of x this time. And then at -2, +7 is the vertex for the f of x function. So now remember, we're starting at f and moving to g. So this time, to move from f to g, we're going to need to move to the left 1, 2, 3, 4, 5, 6 units. And then we need to move down 1, 2, 3, 4, 5 units. And then we put that together into a statement. So Mary can create the graph of g of x by translating f of x, left 6 units, and down 5 units. All right, one more type of problem we need to take a look at. Let's take a look at this one. So we want to write a quadratic function in our vertex form that has these given transformations. So a reflection over the x-axis, remember, affects a. In fact, it makes a negative. A vertical stretch by a factor of 3 tells us that the absolute value of a has to be equal to 3. And then a translation left 4 units tells us that h would have to be equal to -4. And a translation down 7 units tells us k has to be equal to -7. So then we'll plug in those values and concepts, putting these two things together. So we have our f of x equals, and for the a, its absolute value has to be 3, but it has to be a negative number to create the x-axis reflection. So we know that that gives us a -3 for a. And we have x minus the h value of -4. Don't forget the quantity squared. That's an important part of the structure here. And then we have plus the k value of -7. Now there are a couple of things that would be expected that we would simplify in this situation. Minus a negative would become plus a positive. And instead of plus negative, we usually write this as minus. So the finished function in its preferred form would be f of x equals -3 times x plus 4 quantity squared minus 7. And that's the form you've been working with in the other types of problems, where you've been working with the translations, the transformations. All right, let's take a look at one more of those. So for this one, again, we're looking at writing it into our vertex form here. So we have to figure out what our parameters would be. So vertical compression by a factor of 3/7 tells us this is going to affect our a value. In fact, the absolute value of a has to be 3/7. And then we have a translation right 12 units. So that tells us that h, because h is all about horizontal translations left and right, would have to be positive 12. So plugging that in, we have f of x equals our a parameter of 3/7, x minus our h value of 12. Again, don't forget the quantity squared. And then there's no k value, or we could say k is 0, so we don't include it. And that doesn't need to be simplified. So this is our final function. All right, if you'd like to try practice, pause here. That would be the answer to the practice problem here. There's a second practice. If you'd like to try this one, pause here. And there's the answer to that one. And then here's your closure. Pause here to think about your closure. And the results of your closure. This